Hello, my name is Abigail Nagel, and I'm going to talk to you guys today about ocean-wide tracking of pelagic sharks, reveals extent of overlap with longline fishing hotspots. So to start off with a purpose on what the authors were hoping to accomplish with this, they wanted to determine the movements and habitat preferences of both sharks and longline vessels. They also wanted to identify the areas in which both the sharks and the commercial vessels overlapped. So how they did it, they used distributional ranges with distinct environmental heterogeneity. They also satellite tracked over 100 individuals for over 8,000 days. So in total, they tracked about 113 sharks. In that 113, they had about 38 blue sharks, 15 short-fin mako sharks, 1 long-fin mako shark, 32 tiger sharks, 12 great hammerhead sharks, and 2 scalloped hammerhead sharks. And then in order to figure out where the longliners were, they used a simultaneous vessel monitoring system, or VMS, and then also global positioning system, GPS. And for the longliners that they tracked Spanish and Portuguese longliners, and they tracked about 186 in total. So to start off with Figure 1, Part A, this map is a map of fishery-independent satellite tracking, geolocations of oceanic and coastal sharks in the North Atlantic Ocean, and this data is from 2006 to 2012, and it's from spring to summer. So on the map, we can see the circles represent different sharks and different shark species. So the brown circles, these brown circles all around here, those would represent the blue sharks and their movement. The white over here is the tiger sharks. The orange all up around here would be the mako sharks. And then the black, which is pretty hard to see, are both species of hammerhead sharks. So this is also part of Figure 1. So these are two different graphs that represent different time frames within the year. So B, this is the movement and number of days they spent in each location from autumn to winter. So you can see over on this coast they spend more time on average, going closer to about 169 days, whereas over here in this region they only spend typically 1 or a couple more days. Then C is a map of all of the current tagged geolocations of sharks. So whenever they conducted this study, this is where each of the sharks that they had tagged, this is where they were pinging and where they were spending that time on average at the very beginning. This is another part of Figure 1. So this map is what the authors calculated to be the hotspots of the sharks. So these red areas, those are the hotspots. So that's where they calculated on average they would spend the most time. And then all of this blue surrounding it, that would be the cold spots. So that's where they only spend a couple days rather than large amounts of their time trying to feed in these red spots. Okay, hopefully this graph is readable, but this is the statistical analysis from looking at their habitat preferences. So just to clarify a few things before I start talking about it, SST is the sea surface temperatures, so it is exactly what it sounds like. That is the temperature of the surface of the sea that they are in. And then SSH is the sea surface height. So this is the height of the sea surface above a reference ellipsoid. I hope I pronounced that correctly. So to begin with this graph right here, so this is focusing on our blue sharks. So with them, we can see that this area, which is chlorophyll A, this is the productive area, so there's a lot of primary production going on in this area. This is the area they preferred. Then moving on to our second graph, these are our mako sharks. These ones preferred pretty much the same to the blue sharks. But they also preferred the SST gradients and also the primary production. Then moving on to the tiger sharks, they also preferred the SST gradients. So both of these species preferred whenever there was a gradient within the temperatures on the surface. Then finally for hammerheads, they preferred also the SST gradients. They preferred the irregularity of the sea surface temperature, but they also preferred the high productivity areas. Then for longliners, we can see they also had a tendency to go to the high productive areas. And then also on this end of the graph, we can also see that they tended to stick to frontal areas. This is their figure 3. So all of these maps are showing the annual and seasonal distributions of Spanish and Portuguese longline fishing efforts. So we have graph A here, or not graph, map A. This shows all of the entire distribution of longliners from 2003 to 2011. So this black area that we can see, that's where they predominantly reside. Map B is the same information as map A. It is just put into how many days the longliners spent in each of these locations. So we can see that these more red and yellow colors, red, orange, yellow, those are more of our hot spots. So they're spending on average a lot more days than these green areas where they could be only spending a couple of days. Map C, this is their core fishing areas, but this is for the winter, so December to February. We can see that the predominant hotspots that were in the above maps, they are pretty similar, although they are a little bit smaller, so they might not be spending as much time in the winter in some of these areas. Then for D, this is the map for spring. So this is May to March. So again, this hotspot in particular is pretty large, so this is a hotspot definitely should be keeping in mind because they spend a lot of their days fishing here, whereas some of these other spots have gone down a little bit or they've shifted. And as you can see in this one, we have a little hotspot over here, and in the spring they do not fish there as often or for as long. Then for E, this is the summer, so this is from June to August. So again, we still have this predominant hotspot, although it shifted a little bit to the left to focus in this area rather than this whole area. And then this hotspot down here has shrunk a little bit. Then finally for F, this is this is for autumn. So this is September to November. Again, we have our hotspots back up in here and then over here and down here. So these are the predominant hotspots that we want to keep in mind when we're looking at maps of the sharks and which hotspots they frequent. Okay, this is figure 4. So all of these maps represent oceanic shark and temporal overlap with the longliners. And also before I start with explaining these maps a little bit more, the authors did state that they only looked at mako sharks and blue sharks with these overlaps just because they make up about or over 95% of the shark overlaps. So to begin with map A, we have the distribution of all temporal co-occurrence over studied times. So this is for the entire study date, all of the data they looked at. This is all of the overlap that occurred. So the closer to red you get, the more overlap frequency there is. And then the closer you get to yellow, the less overlap frequency there is. And then also with this map, there are white dotted lines all around here. Those are the edges of hotspots that the authors calculated, and you can refer back to the map with red and blue for the hotspots and the cold spots to get a better understanding of what or where they place those dotted lines. Then for map B, this is all the data from 2005 only. So as you can see, we still have the pretty similar overlap pattern as the first one, but we have it concentrated mostly to here, where we can see more red than anywhere else within the graph, although it does look like there is a little bit of higher overlap frequency over here as well. Then for map C, this is all of the data from 2009 that they used. And as we can see with the one above, or the one before, most of the overlap happened over here, with a couple of higher overlap frequencies as well on this side. Okay, now I'm going to talk about the results a little. So the authors found 80% of movement overlapped with longliners, and then also that the observed spatial and temporal co-occurrence corresponded to areas of high seasonal fishing effort and/or shark hotspots. So both of these pretty much go together. What they're both saying is that with the 80%, that means 80% of the sharks' movements, which are the blue shark and the mako shark for these, since they make up over 95% of pelagic shark landings, these two sharks are overlapping at a high percentage with the commercial vessels. So that means, especially with conservation, they are at a high risk of getting injured or possibly getting killed from any fishing equipment or even boats they come into contact with when they're in these hotspots. And then also they have a high risk of bycatch as well, especially with like the seasonal, because these sharks are typically going very often throughout the year and spending long amount of times at each hotspot. The same with these fishing vessels, which are spending over 100 days typically at their highest in these different seasonal fishing hotspots. They also found that the predominant overlaps occurred in the frontal regions of Gulf Stream and near MAR southwest of Azores. I hope I am pronouncing that correctly. So these are just the areas within the oceans that they were looking at that these overlaps occurred the most at. And you can see them present in the maps as well, where you see most of those hotspots happening in typically two different locations. Then finally, they also found that the intense exploitation that was happening in the Gulf predominantly happened during the summer times. And then they also found that the intense exploitation in MAR Southwest happened in autumn for these longliners. Okay, I want to talk a little bit about the significance of this paper. So overall, this research can help us understand movement and patterns of these pelagic sharks a lot better. And then also the interaction of sharks with longliner hotspots. So with conservation directly in mind, this study definitely helps us understand a lot better when and where these sharks will be within the oceans. And it can also help us just track the sharks' movements at different seasons with the longliners, so that there could potentially be a change in how longliners are run or where they are run more often. Also, this research could potentially open up the creation of new or stronger regulations for fishing longliners, because sharks' biggest threat these days right now is fishing like this. So fishing with longliners, any type of major fishing companies, their equipment typically can injure, trap, or kill these sharks, and also with bycatch. So these sharks play a huge role in their ecosystem, and knowing this information could potentially ensure their future protection from fishing corporations. So although this is still, I would say, a little bit of a smaller scale paper, because especially with the overlap, or looking at the overlap of the longliners and sharks, we're only really looking at 2 species. I think if this paper were to go on and potentially look at even more species, especially larger species that might have or might be more susceptible of injury from these fishing longliners, I think it could mean, or I think it could give us a lot of information on how we need to go about changing either the longliners, how they fish, the equipment they use, or even just fishing at different time periods than when these sharks are typically in these hot spots to avoid this overlap. Thank you for listening to my presentation.